All right, today we're going to look at particular pattern of inheritance called multiple alleles. And this pattern of inheritance is when you have two or more alleles or versions of a gene that are present for a particular trait. And so an example that is just a kind of a classic example is with blood types. Blood typing is dictated by a pattern of multiple alleles. And so what we'll look at here is, let me get my pen. In multiple alleles and blood typing, you've heard of probably different types of blood and what's rare and what's not. But you have what we'll say there's an allele for producing what's called A antigens, and there's an allele for producing what's called B antigens. And there's also a recessive allele that produces no antigens. And right now you're probably thinking, what are antigens? And the best way to think about antigens is they're like an ID card that are on the cell membrane of your blood cells, and it tells your white blood cells that they belong. And so if you have A antigens, that means that your white blood cells, your immune system, know that that is okay, that those are not foreign cells, which means that you'll produce something called an antibody or a B antibody, which would fight off any blood cell that had a B on it. And so if you had any B antigens, that would mean you would have these A antibodies, which would result in, if you had B blood and you had any cells with A antigen on them, your immune system would fight those off. So let me explain that a little bit further in a second. But what's important is that when it comes to these alleles, these two are dominant, and then the no antigen allele is recessive. And so you know that people have type A, B, AB, and even O blood. And so if somebody has type A blood, what their genotype is, based on the multiple alleles, is it would be IA, or they could also have IA little I. And if they were type B blood, they would have IB, capital B, or they could have capital B, little I. And then if they had type AB blood, they would have A and B. And this is an example of codominance because both alleles are present and they both are going to show up. So this would be codominance, and then type O blood means you would just be little I. You would not produce any antigens. And so if you remember, if you have AB blood, that means that you don't produce any antibodies for A or B. So what this is known also as, if you have AB blood, is that means you could receive blood from A, B, or O. So if you have AB blood, you are known as a universal receiver, because you don't produce any antibodies, so you could get blood from anyone. And if you're type O blood, that means you're a universal donor, because O blood doesn't have any antigens on it, so it can be donated to anyone who needs it. Okay, we'll do a quick example using multiple alleles. And I don't know if you guys know who Charlie Chaplin is. He was an actor back in like the 1920s and 30s. He was involved in a legal battle over paternity of a child to a Joan Barry. And so the question here is, if Chapman was AB blood and Barry was O blood, and the child's blood type was A, is it possible that Mr. Chapman could have a child with Barry? Should he pay child support? And so the way we do this is just like all the other examples really that we've done, but we're going to write down all the information that we know. So the genotype of Chapman would be AB. The genotype of Barry, if she's O, is little I. And if the child is type A blood, the child could be big A, or big A, little I. And so if we remember, we're gonna here's our cross, here's our parents, right? We've got big I, big A, big B, and then little I, and then we'll run our Punnett square here, our hashtag. I'm sorry, my handwriting isn't great. So we would get a Punnett square that looks something like this. And so back to our question, is it possible that Charlie Chapman and Joan Berry produced a child with type A blood? And the answer is, well, actually, yeah, it's a 50% chance that they could produce a child with A blood. So should Charlie Chapman be required to pay child support? That would be yes. Most likely, they did have a child together. I hope this helps, and have a nice rest of your day.